So in this video, we're going to solve another type of the weighted average cost of capital exam-like question, in which we're going to be looking for not the actual WACC, but we're going to solve for the missing cost of equity or the missing cost of debt. Now, this is a question that students typically tend to struggle with on a final exam. And that's why this video will provide some much needed clarity on the steps to take. And we're also going to throw a curveball at which you're not going to be given the equity to value, and you're not going to be given the debt to value. So you're going to have to use a debt to equity ratio method to solve for those two variables, and then we're going to be able to solve for the missing variable. So in this question, we're going to be looking at two different sets of solving for this missing variable. One, the cost of debt, then another question, we're going to solve the cost of equity. Okay? This is how we're going to go about it. This is something that you need to master if you're taking an intro to finance course, or you're doing a finance review during MBA or master's, or you're slowly starting to re-prep yourself for your CFA level 1. So let's go ahead and let's look at this question at which we're going to be required to solve for the before tax cost of debt, given a bunch of different information. Okay, so let's go about it. Orange Telecom has a capital structure that is only composed of debt and equity. All right, now even before we proceed to reading the question, I think I skipped a step. And that would be to always get your formula ready with you. Have your formula sheet with you, because when you're looking at the weighted average cost of capital chapter, you're really only looking at one formula, and that's the one for WACC, right? Cost of equity times the equity to value plus cost of debt times 1 minus the tax rate times the debt to value. That's the only formula you need. And why it's really important is because, well, you want to look for the parameters that you have within the prompt and try to match them with the parameters within your formula. Because oftentimes, it's only a game of solving for a missing variable. You don't need to look at anything else. There's only a few variables you need, and most of the time, they will give them to you. All right? It's as easy as that. Now let's proceed. In this case, they told you that the weighted average cost of capital is equal to 11.36%. Now, some bells should be ringing, because you're seeing that they're already giving you the WACC, so it's probably not what you're going to solve for. And they're also letting you know that the cost of equity of the firm is equal to 17.46%, while the debt to equity ratio of this company trends towards 0.65. That's very interesting. So they gave you a bunch of information that you need, but they also gave you the output of the formula that you will literally only need to use for this chapter. So let's look at our mission. The mission of this question is to find the firm's before tax cost of debt if the tax rate of the firm is equal to 40%. So now you have a bunch of information. Now we're going to double down, we're going to walk through the prompt, and we're going to try to put some context or identify what are the things that we've highlighted and why do they matter for us in such a question. So we're going to zoom in a little bit, just like that. All right. And they're telling you, and if you've seen previous videos, sorry about that, I'm trying to get a little closer to the screen and to my table, my bad, to my desk. But if you saw my previous video on how to use the debt to equity method when solving for WACC, you would understand that having a capital structure that's only composed of debt and equity is actually pretty irrelevant, because we're going to use that to our advantage, okay? That means that the value of the firm will be equal to the proportion. Well, not even that. The value of a firm, if we want to be like more literal, will be equal to the market value of debt plus the market value of equity. And why that's awesome is because if we understand this, we could also say that, oh, you know what? The proportion of the firm, which is 100%, right? Well, that can be equal to the proportion of debt to value plus the proportion to equity to value. Because we know the value of the firm is composed of those two units, we could say, well, the proportion or debt over value plus a proportion of our equity over value, well, that's going to give us the total proportion of the firm, which is 100%. Hopefully that's clear. And if not, we're going to walk through and we're going to try to visualize this afterwards within this video. But there is also another video that's literally just dedicated to the debt to equity method. Okay. Anyways, enough about that. Let's go ahead and let's look at what they gave us here. So I think I'll zoom out a little bit just to be such that you can see more. They gave you the answer of the formula already. I told you that the WACC is equal to 11.36%. And this is very interesting because they gave you the output of the formula. So already there, some bells should be ringing for you because it would mean that we're not solving for WACC. We're going to solve for something else. And you already noticed here that we're going to solve for KD. So that's important to understand. And then they're going to give us more information and they're going to let you know that the cost of equity in this case is equal to 17.46%. That's awesome. And they're also letting you know, as I mentioned later, previously, the debt to equity ratio trends to 0.65. So debt to equity is equal to 0.65. And once again, what does this mean? Your debt to equity ratio is simply your market value of debt divided by the market value of equity. In this case, this is giving us 0.65. And later, at step 1, I will show you what is the gymnastic or the steps to take in order for us to solve for our equity to value and our debt to value and why it makes sense knowing what our debt to equity ratio is. Now in this question, they're telling us that we need to solve for KD. Well, if you notice, they didn't give us KD, so of course that's going to be our missing variable here. And they also gave us our TC, which is our tax rate. And it's equal to 40%. So on an exam, or when you're just practicing, I really believe it's very good to highlight all of these different pieces of information, okay? And put some context in them. In this case, I'll go ahead and I'll use a different color just for it to be comprehensive. We were given our WACC. We were given our cost of equity. We were not given our cost of debt. So that's important. We were given our TC and we were not given our equity to value and we were not given our debt to value. So although our main purpose in this question is to solve for the cost of debt, well, the before tax cost of debt, we definitely do need our equity to value to do that. And we definitely do need our debt to value. Now, there's definitely a really good trick that we could use here to solve for our equity to value and to solve for our debt to value. And that's going to be step 1. Step 1 is going to arm us with the tools to be able to solve for the equity value and debt to value through the debt to equity method. It's going to be extremely comprehensive and extremely easy to do once you've done it once. And also, by the way, I know I'm repeating myself, but you could definitely go watch my video on the debt to equity method, in which it walks you through all the steps and all the rationale needed, okay? But here as well, I'll explain it, and hopefully you understand how to use this trick. This is a comprehensive final exam question, okay? So let's zoom in. Actually, yeah, we'll zoom in, why not? We know, all right, because now we need to solve for EV and we need to solve for DV, my bad about that. So we're solving for these two variables. And we understand that our debt to equity ratio is equal to 0.65. And the reason why this is really cool is because we could go ahead and highlight E and move it to the other side of our formula, such that we could argue that D, okay, is equal to 0.65 E. Okay? And this is some very, very, very cool stuff. Because if we know that D is equal to 0.65 E, and we understand that the market value of a firm, right, is simply the sum of our market value of equity plus our market value of debt, and we understand that that's literally like the entire pizza that we're sharing, right? Think about it like that, like the entire proportion that we have. Well, if we find a proportion allocated to equity or value, by definition, we'll be able to find a proportion to debt over value. And because we know this little trick that we use, because they gave us our debt to equity, we could go ahead and simplify this little formula here. We could say that debt over value could be written as, right, because we know that debt is equal to 0.65 E, we could remove this and write it as being 0.65 E over V plus E over V, and that's going to give you 100% of the value of the firm. So with that, we could actually find a proportion that's dedicated to our equity value, and by definition, we could find a proportion that's dedicated to our debt to value. Notice how this is extremely similar to Chapter 8 or Chapter 9, right? Portfolio theory and the capital asset pricing model, also known as CAPM. Remember how we had to work with weight of A plus weight of B? Well, we're kind of doing the same thing here. Here we have weight of debt and weight of equity type of thing. Thus, once again, hence the title weighted average cost of capital. Just some additional context, right? That could kind of like tie in the nuances and the gaps in this chapter. So now that we have that, we could go ahead and kind of use this for to our advantage. So we know that 0.65, all right, E over V plus E over V is going to give us 100%. 100% is synonymous to 1, by the way. What we could do to make this a little bit easier for us is we could highlight E over V, because students typically don't like to play with fractions too much, and it's fair, I get it. They're not the cutest thing out there. So we could go ahead and kind of simplify this a little bit more. We're going to call this, you know what, why not? We're going to call it X, okay? So we're going to place E over V as being equal to X, and we're going to solve for X, right? We're going to solve for our equity over value. So what you're going to do is you're going to write this as being as follows: 0.65 X plus X is going to give you 100%, or 1, really up to you. So now that we know this, we could actually solve for X, and I'm going to go ahead and do this with you because it's my first time solving this question. So let's do this. 0.65 X plus X gives you 100%, such that you could either use a fraction or you could, just get a decimal point. It's really up to you. In this case, I'm lazy to write the fraction. I don't think you'll love it either. And we're going to write 0.0606, such that we could say, you know what, X, which is our equity over value, is equal to 60.606%. And this is awesome news. The reason why this is awesome news is because now we know our equity to value. And because we know our equity to value, for sure, by definition, we know our debt to value. So let me go ahead and write this as being 60.606%. And we're going to write, I don't know, our debt over value in another color. We'll put it like orange. So if we know that that's equal to 60, I'm just going to kind of write these. So we know that if we do that, 100 minus 60.606, we're going to get 39.394% as being our debt to value. Is our debt to value. So that's awesome. So now that we have that, we could actually try to like portray this within our little market value circle here. Once again, we're looking at a pie chart because we're going to use the pizza analogy or the pie analogy. So let's go ahead and do that. We know that 40% is going to be allocated towards, essentially, well, 39% is going to be allocated towards our debt. So we could go like this and say that this is equal to, it's kind of big, to debt. Then we could say that the remainder is allocated to equity. Okay. Now this is extremely, extremely, extremely important. The reason why this is extremely important is because now what we highlighted before as being unknowns is like boiled down to only one unknown, which is our mission, which is the cost of debt. Because now we know what our EV is and we know what our DV is, such that we only need to solve for our cost of debt. So what we're going to do is we're going to work through this together as a team. We're going to walk through step 2, which is solve for KD. We're going to identify the variables. We're going to plug them in together. We're going to work through this together, and you're going to see how easy it is to solve for our cost of, gosh darn it, debt. Okay. So let's go ahead and do that. I'm going to use purple. Why not? So we know that our WACC is equal to 17.46%. So 17.46%. I'm so sorry. I'm bugging, yo. I'm really bugging. It's 11.36, my bad. So 11.36% is your WACC. That's your like cost of capital. Your cost of equity is equal to 17.46%. And that's going to be multiplied by essentially 60.606%. I'm sorry that that's ugly, but I don't have a lot of space. And then we have our cost of debt, which is what we're solving for. So we could say x multiplied by 1 minus 40, which is what we're going to call as being simply 0.6 times 39.394%. And we're going to solve for the missing variable. Okay. So what we're going to do is we're going to say, okay, well, we know 11.36% is equal to 17.46 times our 60 point. That's going to give us 10.5818. So that's going to be the proportion allocated, all right, to our cost of equity. And now we're just going to look at, I guess I'll have to zoom in a little bit because it's getting kind of ugly. But you know what? I don't care. We're working through this together. So then we have 11.336%, which is our cost of capital. We found that the portion that's dedicated to our cost of equity, which is going to be 10.5818%. Now we need to look a little bit deeper into our cost of debt. I'm gonna go ahead and zoom in just because I'm tired of writing like a barbarian. It's not looking good. So we could go ahead and actually solve for, and I'll write this on orange. We could just multiply these two together because we know those are whole numbers and we're solving for x really, right? So what you could do is you could do 0.6 times 0.3934. That's going to give you 0.2364. Okay. And then if you really want to be like super duper like crazy about it, you could write this down in a nicer format. So you could say, you know what, 0.1136 is going to be equal to 0.105818 plus 0.2364 x. Then it becomes a game of solving for x. So what you could do now is you could actually just plug this in within your formula. And I'll open another symbol lab and we're going to do it together. So let's solve for x. What would be our x? Hopefully I didn't make an error along the way. And you're going to get 0.03291. In other words, you could say that your cost of debt is equal to 3.291%. Now we definitely do have perhaps a small rounding error, which is totally fine because we definitely did round up some portions along the way. But on an exam, you would have plus minus 1% kind of like margin of error. And I'm okay with this. Obviously, if you were to be super like, critical about it and you were to solve every single step along the way without rounding errors, without making any like rounding error along the way, without rounding up anything, you would get the correct answer. But what I want you to understand is that this is a really good way to solve for your cost of debt because this would be, once again, your cost of debt, right? So that's how you find a missing variable. And I'm okay with this. Now, let me know if I made like a small error along the way, but this is probably as okay as it is, right? Because if you had a multiple choice, you would just take the answer that's closest to your correct, what you got here. 3.291 is pretty darn close to 3.33. Of course, we did a lot of rounding along the way, but this is more so to show you the steps, okay? Now, if you had to fill in the blank, I still believe you'd be fine. So that's how to solve for the cost of debt. Now, the steps will be extremely similar to solve for the cost of equity. Okay, so let's go ahead and do another question at which we're going to have to utilize all the same techniques, but instead of solving for the cost of debt, we're going to solve for the cost of equity. So let's go ahead and do that together right now. So notice how it's the same structure again. And now we're going to solve for the cost of equity. So Orange Telecom, their capital structure is composed of debt and equity. All right. Now in this question, we're going to kind of run through it like if we were on an exam. So we know that debt plus equity would give you value of the firm. And by definition, we could say that D over V plus E over V is going to give you essentially 100%. So that's pretty cool. We were also given the weighted average cost of capital, which is equal to 6.72%. So we could say WACC is equal to 6.72%. And we're also letting you know that the cost, actually, we're going to go to another one. This is the same question, my bad. We're going to go for one where we're looking for the cost of equity, my bad. This one, we're looking at the cost of debt still. So I'm going to go ahead and move on to one where we're looking for the cost of equity. Sorry, I want to give you two views, right? Because we're looking at two different methods. So same old thing though. Capital structure only composed of debt and equity. So we have D over V plus E over V, and we know that that's equal to 100%. Here they gave us the WACC, and they told us that the WACC is equal to 4.06%. All right. And we also know that the before tax cost of debt of the firm is equal to 2.7. So we could go ahead and write this as being equal to KD, 2.70%. We're also letting you know, well, you know what? The debt to equity ratio in this case is equal to 0.9. So we could write this as being debt over equity equal to 0.9. Now our mission for this question, pretty straightforward, very similar to the previous one that we did together. And it's going to be to solve for the cost of equity. That's something that we don't have, something that was not provided, and it's going to be our missing variable for this question. We're going to solve for KE. So that's equal to our missing variable. Now we're also letting you know, well, check this out. The corporate tax rate in this case is 25%. Okay. So if we were to go ahead and look at our WACC formula, right? We would notice that, you know what, we have some things here. We could work with these numbers. Okay. We have our cost of debt, which is awesome. We have our WACC, also dope. We have our tax rate, and we have our debt to equity ratio. And by definition, if we only have those variables, then we're missing our cost of equity, we're missing our equity to value, and we're missing our debt to value. But don't you worry. Because we understand how to use a debt over equity method, we could actually solve for our EV and our DV fairly quickly and fairly easily. All right. So let's go ahead and do that. I'm going to use a different color. Let's go with green, for example. And let's try to solve for EV and let's try to solve for DV. So I'm going to zoom in a little bit such that we could actually have some nice, cute notes. So if we know that debt over equity is equal to 0.9, we could go ahead and simplify this by moving our equity to the right-hand side of the formula and say that debt is equal to 0.9e. The reason why this is important, and you should be a seasoned vet by now, this should be light work for you, is we recall that the value of a firm is composed of the market value of equity plus the market value of debt. And because we know that the value of a firm only consists of those two, especially in this context, we could say, well, you know what? The proportion of debt to value plus the proportion of equity to value will give us 100%, because we're splitting our pie into two pieces, right? The piece allocated to debt and the proportion allocated to equity. A really good, I guess, analogy or like comparison tool here would be to think about a pizza that you're sharing with your significant other, right? Let's say the pizza only has, call it, I don't know, 8 pieces. Well, some of those pieces are going to be given to you and some of those pieces are going to be given to your significant other. However, it's not always a 50-50 split. Sometimes it's going to be a 10, right? Like a 1 piece of pizza to 7 pieces of pizzas for somebody else, right? So you could like break it down into different steps. And having that in mind, and don't you worry, we're going to visualize it more like we did in the previous question. But having that in mind is, well, if we know that this is equal to, D is equal to 0.9e, well, we could go ahead and replace that on our formula. So we're going to go ahead and, you know what, say, no, D is going to be written as 0.9e, such that you could argue that 0.9e over v plus e over v is going to give you 100% of the firm, right? The proportion, the total proportion. So let's go ahead and use that to solve for EV. So if we know that 0.9 times E over V plus E over V is equal to 100%, we're going to go and simplify this a little bit further though, because we want this to be easy for us. We're going to highlight this, right? And we're going to essentially translate E over V, so equity over value, as being our X, our missing variable that we're going to solve for in this specific instance. So we could say, you know what, this is, oh, I'm going to write it here then. This is going to be our X, right? E over V, because we don't like playing with fractions, we're just going to call it X. And then we could solve for X really easily, super quickly. So let's go ahead and do that. We could write this as being 0.9 X plus X is equal to 100%. And we could say that 100% is equal to 1 really, such that you could argue that X is equal to, what is it equal to? Let's figure it out. It's my first time doing this question as well. So 0.9x plus x is equal to 1, such that x is going to be equal to 52.631%. So we could say 0.52.631. All right, that's going to be our equity over value. So I could go ahead and even like maybe write that over here. So we could write this as being E over V, very important. So now that we have that, we could go ahead and go back to our little framework here and say that, you know what, E over V is equal to 52.631%. And if that's E over V, well, we could solve for D over V because we know that the remaining like proportion, the remaining piece of like the pie is going to be simply equal to 100% minus 52.631%. So I'm going to go ahead and do that. Make sure I didn't make no errors. 631. So we know that the remaining piece of the pie, debt over value, which I'll coin in a different color. I don't know, let's call it this one here. We could call it as being simply 47.369%. Now, why is this pretty cool? Is because we could go ahead and kind of try to visualize this within this little like value pie that I built here. Okay, it's nothing too crazy, but hopefully it draws a little bit on some concepts that you would require. Okay, I guess we'll go like this. Okay, so what I'm going to highlight here now is we're going to highlight in pink the proportion of the firm that's essentially dedicated to equity. So you notice that, well, if we look at the like our pie chart, we see that a little bit more than half of the firm's value is allocated to the market value of equity, whereas a little bit less than the half of the firm's value is allocated to the market value of debt. So we could go ahead and like draw it like this. So that's like a good visualization tool to use here if you ever need like another perspective to take. So now that we have all of this, we could use this to our advantage because now we know our DV. So we can maybe even like go highlight that if you want. We have our DV, we have our EV, such that the only thing that we need to solve for now is our, not even our KD, my bad, it's our KE. All right, so let's go ahead and plug everything in within our formula and try to work with this. So I'm gonna zoom in a little bit more just because I want it to be comprehensive. So once again, we know our EV, we know our KD, we know our TC, and we know our DV. However, we're still solving for our KE, okay? So we don't have that just yet. And we know our WACC. So what I'm gonna do is I'm gonna highlight all of these different pieces of information, and I'm gonna try to find our stuff. So we know that our WACC is equal to 4.06%. And I'll put this in a different color just for jokes. Let's go with, I don't know. Let's go with purple. So we know that our WACC is equal to 4.06%. We know that our KE is equal to X. And we know that we're going to multiply that essentially by 52.631%. All right. And in this case, we also know our KD. Let's go ahead and highlight what our KD is. Our KD is equal to 2.7%. Okay. So we could say, well, all right, 2.7% multiplied by 1 minus 25%. Multiplied by, and I'm sorry that it's a little bit cramped, but I'm trying my best here, by 47.369%. Will help us solve for a missing variable, which is X. So what we're going to do is we're going to make this a little bit cuter. We're going to make this something that could actually work for us. So we're going to go ahead and we're going to just multiply all of these together. Because why spend our time working with this if, we already have the value. So what we're going to do is we're going to do 2.7% times 0.75 times 47.369%. We'll go ahead and do that. Just give me a second. Cool. So we're going to have 4.06% is equal to 0.52631 X plus, and if I were to put this as a number, I guess I'll do that. Plus 0.0099592. We could go ahead and solve for X. What we're going to do now is we're going to plug everything in. We're going to do just that. So now it's just a question of solving for a missing piece of the question of the equation. And if you want, you could even go ahead and do 4.06% minus this, and then just solve for and isolate the missing variable. But I'm going to do it in one shot just because I'm a lazy person. So we're going to have 0.406 0.09592 we could go ahead and solve for X. And we would say that X is equal to 5.891. Let's see if I'm even close. So yeah, it's pretty darn close. And of course, because we have some rounding errors along the way on an exam, you would choose the answer along the choices provided as closest to 5.891%. For sure, we had some rounding errors along the way because we actually had to round our answer up. Now, depending on how professors build their questions, they may be using Excel, they may be using, just a calculator in their hand, and they're rounding along the way and they're making mistakes along the way. You may have to choose something that's closest to the answer that you got. Now, if you have to fill in the blank, you're chilling because you just have to write in your answer, and typically the exams will give you a margin of error of like plus or minus 1%. Well, of the answer. Anyways, you get what I'm saying. So what's awesome here though is that we just had to solve for the missing piece of variable. In this case, the missing variable, the missing piece of our WACC formula. And in this case, instead of solving for the output that is WACC, we solved for KE. And we noticed that it wasn't that tough. We just had to find our EV and our DV, but once we had that, we had all the variables. We just had to solve for this exact specific missing piece of the puzzle, which was our cost of equity. Now, I hope that this video helped you out. I hope that it gave you context. It's not the cutest one to do when I'm trying to like go through like these specific boxes, but the idea here remains is that you just got to take your time. You just got to identify the pieces that you have, and then solve for the missing variable. And hopefully this video gave you some context on another sort of question you may see on an exam. All right. This is a question that is definitely an exam like multiple choice. You will see this, and it's something that you may see under projects or assessments or whatever. And what's also important is that now you know how to solve a very interesting beginning portion of a very complicated WACC problem that touches on a bunch of different chapters. So yeah, hopefully this gave you context. Hopefully this helped you out. I don't know. I don't know if this is the solution to making this, a very fun course for you. But at least it's one step towards that, I hope. And if you need more context, if you need more questions, if you need more videos, don't hesitate to go on my YouTube channel or on my website. You're going to find a plethora of content, or at least a bunch of attempts to make this something more inspiring, more human, something that's not static, and to give you clarity of mind and to make you understand that, yo, if a fool like me could do this, you like 100% could walk through this class head up and actually score really well. And at least that's what I pray could kind of happen for you. I know you're awesome. I know you got this. Don't feel stressed. Study smart. Work through the parts that you really don't understand and use my tools to help you out in that end. Okay? Anyways, enough of that. Hopefully this helped you out. And with that said, I hope you have an amazing day or whatever, and just keep on working hard because you're awesome. Okay? I'll see you in another one. Au revoir.